and today I'm going to talk about local intelligence, running LLMs offline on this machine. Hi everyone, and welcome to Brisbane User Group by SSW. I'm JK. You can call me Jernej Kavka, but I know my name is very easy. And I'm a SSW solution architect, and you can follow me with all of these socials from X, Twitter, GitHub, LinkedIn, and all of the others. I'm one of the organizers for the Brisbane Full Stack User Group, this one, as well as host for the Global AI, the podcast. And I'm predominantly a .NET Core and EF Core developer, a specialist in that as a consultant. But I work a lot with AI. I'm a Microsoft AI MVP, and I like to think myself as an AI generalist because I looked at AI since like 2010s. And I kind of saw the evolution, how we got to this point. So that's very, very exciting. And before we start, if you like to win free stuff, you can download the SSW Rewards app. It's a mobile app where you can scan some SSW QR codes and get some really nice swag. Like there we have like a nice cup for your coffee, and it actually shows you temperature. So you can see if your coffee got cold. Hopefully not, because we should be drinking a coffee. All right, so why offline AI? Well, if you are asking yourself that and wondering why you want to have that, well, first off, if you're working for governments, military, or any other company that really doesn't want to have their data around the world, data sovereignty is one of the very important factors. Now, if you use something like Azure AI Foundry, your data is more or less secure as long as you made sure that the connection to Azure AI Foundry is done right. But the problem is, what if the data never must leave the network? Or better yet, what if you don't even have connection to the internet, right? What do you do then? Well, that's where offline AI comes in. Also, you can run it on your own hardware. Like we have seen a couple of times where either Google Gemini went down, ChatGPT went down, a couple of other AIs, like I think Claude had some issues recently. It's not just about the service being online, it's also about the consistency of how much compute they give you to answer your prompts. And you cannot have that consistency with a cloud provider. But when you run your own hardware, your own models, you can show that more easily. You have lower latency, especially if there's no internet. You can actually use your AIs, even if you have, for instance, your laptop without AI, or you have a drone, or you have like an IoT device. You can run everything offline. And there's also better reliability. Like the reliability is dependent on how much resources you throw at this problem. Like if you have hardware redundancy and things like that, you can ensure that your AI model runs reliably. Whereas, if Claude goes down, I guess some people will switch to another AI or just have a little break. All right, so how do we use offline LLMs? Now, there's a couple of ways of using this. One very popular one from the start is the Llama. They were one of the first ones that came out to be able to use LLMs offline. The interesting part here is that you can set it up on Docker, you can set it up in various different ways. If you have a Raspberry Pi, that's probably the way you want to go. What I'm seeing is that sometimes they're a bit slow on adding all of the models, so I prefer another a provider instead. But they are improving significantly. Like, for instance, they didn't have a chat UI until, I think, 2 or 3 weeks ago. So they have published a desktop app that is official by Llama that you can actually now chat with your offline LLMs. You don't have to build your own or introduce someone else's. And it also supports MCPs. You can attach files and things like that. So pretty cool. Then if you want to basically manage everything by yourself, Docker seemed to do a pretty decent job at giving you the option to just download a model and then use it locally. So that's pretty cool. So if you want to manage via Docker Compose and stuff like that, you can do that. So that's one really cool thing. And my favorite one is LM Studio. The reason why I really love LM Studio is because it's done by developers for developers, and then it's like, okay, we'll also add support for users. They supported MCPs before Llama and a couple of others, other desktops supported, not before Claude desktop, but far sooner than ChatGPT, for instance. Any model that gets released, there's a chance that you'll already be able to run it on LM Studio. Like when you have stealth releases of certain models, offline models, there's a good chance that you'll be able to run it on LM Studio. Like Llama, for instance, you may need to wait weeks to get it available or hack yourself to get it done. Here, you just search for it, download, and you're good to go. And it has a lot of configuration that you can mess around. You can do like offloading things on multiple GPUs, multiple CPUs and stuff like that. It's a crazy tool. All in one, simple to use. So if you're starting off, that's the software to use. And when you install any kind of offline LLMs, or if you're trying to search for a specific model online, one thing you'll notice is, what do all of these letters and icons and numbers mean? Like we have here, I don't know, crime-free next 80 billion. Okay, so it's 80 billion parameter. We kind of get what that is. But then we have here A3B instruct 4-bit. So what does that mean? So here, I'm going to explain to you, because I think we do need some guidance on how to pass all of that information, because things are moving really fast. So first off, I want to start with these icons over here. So if you see an eye, it's vision. But that doesn't mean that it can generate image. It means that you can upload an image and it can understand that image, or at least read it. Whether it can understand or not, it depends on how good the model is. Then we have thinking. That's that tells you whether they're a reasoning model or not. It doesn't tell you if it's smart, only if it can think. Well, think. Then we have tool-friendly, which a year ago meant something completely different, but now it generally means that it can use MCPs. Back in the day, it means that if you have an XML that it says, hey, try to call that function, it was able to do that. But nowadays, it's more for MCPs. And then we have the good old regular LLMs. It has no icons. So here we have even more icons and more stuff. So let me pass through what that actually means. So this means that it's a crane-free model. Then we have 30 billion parameters. Now, when we're talking about 30 billions, 80 billions, 70 billions and stuff like that, what generally that means is that's how many parts we have inside the neural network. It's not just the neurons, it's also the connections between neurons. It's very similar to how we talk about CPUs. We say it has this many trillion transistors, but imagine that we also say how many wires outside of transistors also go. That's roughly what these billion parameters mean. Then the instruct generally means that it's been trained to follow instructions. If you see the model doesn't have that, it usually is more for being a chatbot or it has a different purpose than just following instructions. So here the 6-bit means that when we're talking about the 30 billion parts, one part is about 6 bits long. So what that means is that the higher the number, the more bits there are, the higher fidelity there is. But it's similar like with JPEG. At certain point, you will not notice a difference. So some compression is actually good because that actually impacts how big it is. Like here, it's 24 gigabytes. So that would take up on your storage about 25 gigabytes. But more importantly, it needs about 25 VRAM gigabytes space. Also, you need to make sure that you have a little bit extra for your operating system and stuff like that. So this model would probably work really well on 26 plus gigabyte VRAM. If you're on Apple, that means that generally you want to have like a 32 gigabyte RAM plus. This one probably getting closer to 48 gigabytes because you need to also have it for your operating system, some storage. Okay. But that's not all, because in 2025, they came with MOE, which is Mixture of Experts. Now, what that means is that this model that is 20 billion parameters can run with roughly the fidelity of 20 billion parameter model, but the speed will actually be much better than a general model with 20 billion parameters. Because if you notice over here, we have 3.6 billion active at a time. So it would roughly work at the speed of a 4 billion parameter model. So much faster. But it has the benefits of 20 billion parameter model. You do lose a little bit of thinking process, a bit of, you lose a little bit of quality, but the gains are so much better because now what you can do is you can run much bigger models at higher speeds and compensate by just trying to be able to run bigger models. And if you're interested a little bit of a detail, the experts are chosen per token. So it's not like it chooses one expert and just runs with that expert for the entire prompt. For each token, it tries to decide the expert. And yeah, you still need to have full 12 gigabytes available on your GPU or your Apple device, but the difference here is that only about 4 gigabytes will be active at a time, which in the traditional one, it will need the full 12 gigabytes. And last one is the MLX. So usually, if you have Windows machine or Linux machine, you would go with GGUF. But if you have Apple Silicon, you go to MLX because this one is optimized for Apple Silicon. So, okay. Enough talking. Should we try out LM Studio? I see some notes. All right. Yeah. So I need to swap like that. And here we have LM Studio. So I already have, you can see a lot of chats over here. What I really like is you can see that there's a folder structure, which I really love. And if I expand, you can actually have even more folders. So I can actually store my demos and stuff like that. So if it goes something wrong, I can show, hey, this is how it worked. It's a little bit cheat sheet for me. But also I can redo some of the, like for instance, there's a prompt that I have that I want to test different models against. I can save that prompt and then switch between models to see how they respond. Now, if I click on search, you can see here, generally speaking, LM Studio is pretty good at curating the recommended models. What you want to know is that when you click on a model, you can Let me pick one that I don't have. I think I don't have this one. You can easily just click over here, download. And what is really cool about it is it tries to pick a good model from the list over here. So you can see here, and there's different bit sizes, there's different qualities, and there's GGUF as well as MLX. So you can have the option to pick whichever is best for you. Generally speaking, I just leave LM Studio to pick the best one for me. And what is also very important is when you're trying to pick, it will also tell you which ones are likely too large for your machine. So this is really cool because I learned the hard way that actually, even though I have 64 gigabytes of RAM, the amount of RAM that is actually allocatable by AI is 48 gigabytes. But 48 gigabytes is still massive. Like I can download this entire 80 billion parameter model, which on most of Windows machine you can't. So that's all for here. You can search for the models, very simple. But if you're Mac, you may want to disable GGUF and just focus on MLXs. Now over here, does anyone have suggestion for prompt?
Business system, enterprise system?
Sorry?
System like a software, a business.
Yes, so generate me ideas for a business software
To keep making notes?
app to keep notes. Yeah, let's see what's happening. Also, I'll just need to, that comes later. That's pretty fast, don't you think? And here I have a couple of ideas, meeting-driven notes, project management notes, and stuff like that. And if I want to, it's like go with the first idea and draft up a dotnet solution architecture. And you can, I can now offline do this stuff, and I can say, okay, does this look like clean architecture, or does it look this like vertical slices? And then I can say, hey, actually switch the architecture to that one, and stuff like that. This is fully offline. This is not connecting to any of the servers. And currently that I'm using is Coder 30 billion, which in my experience for the stuff that I'm doing seem to be the best. I also use I actually recently done some benchmarks, and it was interesting that Qwen 3 actually was the best one based without a rack integration. But then when we added rack, the Qwen 3 Coder 30 billion beat it. So that's interesting. It shows that the coder is very good at following instructions, and then when it gets a lot of context, the coder was better to handle a bigger context than the Qwen 3. And I have a lot of other LLMs here, and if anyone has any questions, you can submit it in the comments, and I can answer them about the models if you have any specific questions. So see here, we have generated some nice prompt. If I wanted, I could copy the code and try it out. But generally speaking, you have other tools. I think it's Kilo and a couple of others that you can connect LM Studio to them to then use it as an offline Copilot rather than relying on a cloud Copilot. All right, so let's switch back to the presentation. Now, when you use something like Llama, LM Studio, and similar solution, that is equivalent to trying to send a scheduled email to John at 9 a.m. Then the AI generates you the email and then tells you to send the email at 9 a.m. To John. And you're like, no, I want you, AI, to send this email. And the And then the AI will give you even more exact directions on how to achieve that task yourself. So if you're lazy or you want to do automation, that's not exactly what you want to do, right? So instead of that, what we can do is there's a tab for developers over here. If we switch back, you can see here we have a developer tab, and this makes it work similar to Llama. So it's reachable on this localhost endpoint. And by the way, if you use it with React or something like that, make sure that you enable CORS, otherwise it's not going to work. And if you spend a few minutes or hours trying to debug that, you're welcome. And basically what allows you to do here is you can have one or even more. Like I can load an additional model over here, and I can have multiple models available to the endpoints to use them. So that's really, really cool. If you want to do multi-model, multi-agent, for instance, setup, you can have different type of models. Now, what you can also do with that is you can make endpoint calls, web requests. So over here, if I switch to Insomnia, I have prepared a web request that goes localhost 1234 v1 chat completion. Now, this is consistent with the OpenAI, with Llama, with the Azure AI Foundry. So these endpoints are consistent. The structure is also consistent. The only difference is the authentication. That's in LM Studio by default. You don't have to authenticate, so it will work just fine. So if I run this, it's going to always answer in rhymes. And today is Thursday. That's actually not true, but what day is it today? So today is Thursday, you see. Happy sunny decree. It's Thursday too. Don't you fret. A lovely day we won't forget. So let the celebrities flow and have a wonderful show. Sorry. So yeah, it is with rhymes. So you can do a lot of things with that. And another thing that you can do is if you try to automate this, like for instance, you want to run PowerShell scripts or stuff like that, and you like LLMs, so you don't want to install Llama because you need to have Docker running and stuff like that. There's a CLI for it. So when you install LM Studio, you have here we have LM as get, and you can specify the model, and that's actually going to download that model, which is really cool. And then you can start the server automatically from the command line, and then you can also load the models that you have downloaded. And if you want to check which models he has, if we go to, for instance, terminal over here, I can do lms.ls, that's the models that I have installed, lms.ps, these ones are the ones that are running. So if you want to do automation, this is a really cool tool. And there's a couple of other ones that you might be interested in. It's the LM Studio, LMS status, that gives you whether the server is on or off and which ones are loaded. And then LMS, if you want to, for some reason, chat with your AI through terminal, you can do that. You can prompt it directly from terminal. Now, another thing that I wanted to show you is that you can use all of these features in .NET. But this is also true for TypeScript, for Python, and other languages. I just like .NET, so I build it in .NET. And if I switch to VS Code over here, so just to show you a little bit of how the project looks like, this is a Blazor WASM application, so it works completely offline. Because our AI is working offline, I wanted also the application to be able to run offline. And here I just have a UI. It's not too important what it does, but essentially what we have here is couple of text boxes, drop downs and stuff like that. The more important part is here we have a chat client, which is a new .NET 9 AI feature, which I'm going to show you shortly. And I have played around a little bit so that we can actually try out different versions of Home Assistant that I have built. We can call it JK's Home Assistant. And if we look here, in the first implementation that I did, there's a lot of code below, but it's mostly for parsing purposes. And if we look at here, we have a system prompt, and I deliberately made this system prompt very simple. So it's your Home Assistant AI, here's the list of devices, and I just listed the devices that are available and just say, hey, these are the commands that you can do. And then I just did a one-shot JSON. Now, if somebody asks me whether this is a good system prompt, I would say no, but it works. So, and that's where I end my argument, because it works. And I found it that when I tried to over-engineer this prompt, especially on a 8 billion or 4 billion parameter models, they get confused. And they actually work better with a little bit more cryptic that, you know, definitely doesn't have enough information to actually know exactly what it should do. It just barely has enough information. Work better than a highly detailed system prompt, which was actually quite surprising to me. But, you know, you always should test your system prompts against the models that you're planning to use. But yeah, that was an interesting lesson to me. And here I have hard-coded a few things because an example app, but I could change this over here to be something else. And basically, most of it here is just, you know, getting data from HTTP client, passing through stuff, and lots of, you know, if it's Gemini, it's going to do this weird stuff. If it's Llama, it's going to do that weird stuff. There was a lot of trial and error to make this reliable back in the day. I'm noticing that with newer models, especially with higher parameters sizes, I don't have as much problems with some weird exceptions. So most of these contingency code is not running anymore as much as it used to. But the interesting part, let's actually first demo the thing so that you can see what it does. And I made it so that I can switch between different models. So what this does is I can say it's really cold, set AC to 23 and turn on living room lights. Now, this is something that last year Google Home was not able to do. Especially if I just say this, for instance. If I just say it's really cold, it wouldn't do anything. It was just like, yeah, okay, it's really cold. But this rudimental system prompt actually knows to set AC to 22 and to turn it on AC. If I add a heater, for instance, and let's turn off AC, turn off that, and run this again, it's going to turn on heater. System prompt did not tell it to do that. It did not tell it to prioritize heater over AC if they want to warm up. Like if I say it's really hot, it will use the AC and it's going to set the temperature to 18 degrees. So I didn't actually tell any of that in the system prompt, and it just works. Awesome, isn't that? And yeah, there's certain things when you do system prompting, sometimes simpler system prompts works better, but sometimes a more strict system prompt works better. In this particular case, it works pretty nice. And another thing that I want to show it here, I won't go through all of the implementation, but I'm going to go to version 5 and version 6 going to be for the next talk, is the new .NET 9 version. So a lot of code that you've seen earlier was basically just having an HTTP client, doing web requests, and doing lots of different things. And I could show you how I did the parsing thing, but we'll be 10 minutes analyzing the code. It's mostly because it just generated JSON, and then I need to figure out what to do with that JSON, and sometimes it was inconsistent. But you know what's cool? What if LLM could just call the method that does the thing that I wanted it to do? So over here, I have execute device action, I have a description, and here it tells it what this method is doing. So it controls the smart home devices by performing specific actions. Then I have description for each of the parameters, like the name of the device, the action, the value, and the text. And the value and the text are nullable, so it knows that it's optional. And then I can create the device action, which then I added to a list. So I'm building up a list of actions so that I can also display it in the UI, what actions I'm going to execute. That's pretty cool, right? And the way I have configured it, I have here chat options, I specify tools, and over here I said AI function create this function. So here, that is the actual method from above. So it told it this is the method. And then I just tell it, hey, use this function to control the devices. Always call this for each device operation. So that, and you can see how little code there is. Isn't it awesome? It's like magic. Especially compared to that one. Like, I was a little bit lying. The real version that I was using in production was version 3, which has even more code. But version 5 is like what I can push to production and be, should be fine. And, with the magic of, well-designed application, I can switch to version 5, and I can even clear that. And when I send this, previously we got the past action was a JSON. So here it's a text. It tells me what it did, and there is no action over here. So actually, let me show you. So when I do this and send this, you can see the response is the JSON. So I needed to parse the JSON and all of that stuff. Here, let's go with a different prompt. You can see here, there's just text because I did not get a text response of what action I should be doing. Those actions were executed directly. And that's the beauty of it. I can create more methods, and LLMs now are able to execute them directly. So that's really awesome. Like, who is excited to use this? I have a couple of hands. Yeah. So once I saw that, I was like, oh, I don't need to write parsers. I don't need to worry about what format the JSON is or whether it's going to correctly name the property name and stuff like that. It just happens for me. And this AI is, works for the dev AI. What that means is you're trying to send a scheduled email to John at 9 a.m. and then it creates an appointment at 9 a.m. with the content of the email. And you're like, what? Why would you create an appointment and put in the email? Well, it turns out the developer didn't implement the API for scheduling emails. And you're like, oh, fine. I'll send it at 9 a.m. At least I have an appointment and I just copy paste everything in the email. Better than before, but before it was like, yeah, just do it yourself. But can we do better? Well, so most of the code that we have written for LLMs up to 2025 was looking something like that. We we basically wrote some APIs, and usually it was like open API specification, and then we needed to make sure that the LLM actually understood that. And those schemas were sometimes thousands and thousands of lines long. So you're burning through tokens like crazy. And LLM is then confused which of the methods should be used. So there were issues. It wasn't really AI friendly. But here is where the Model Context Protocol is coming, the MCPs. So if anyone didn't know what MCPs is, that's what MCP is. And what it is, it's a simplified communication between LLMs and apps. And a lot of people like to say it's like USB-C, but if you're a developer, it's like Open API for LLMs. And one really cool thing is, if you remember the Swagger and all of those nice tools, it's kind of like that, like auto discovery tools, but for LLMs. Yeah, basically, it can ping a URL and say, "Hey, what can you do for me?" And it can then respond with the tools that are available to that LLM. And what is also very important is that it has different types of protocols that are more AI friendly. There's SDDIO and two others that I'm currently blanking on. So this is roughly how it looks like for LLMs with MCPs. We have something in the middle, the MCP server. But this MCP server gives the LLMs the auto-discovery and a friendly AI protocol, which means that we just need to update this MCP for the LLM to be able to communicate with different services. And usually you will have one MCP per service. And what is really cool about this is that you can actually have two-way communication. You can have an MCP saying, "Hey, you sent a request, but you forgot to send me the last name of the user. Can you send me that? And then I can do the thing." And then the LLM is like, "Oh, whoops, I didn't know you need that. So here's the last name." And then it can execute the operation. With APIs, what would happen is it's going to say, "Error, I can't do this. Here's a really big list in JSON of what went wrong." And sometimes you don't get the information of what went wrong. So this is a little bit more AI friendly of how they can interact, and it can be two-way, which is really cool. And I'm a bit lazy. There's a different MCP catalogs that you can find it. Docker is already installed, so I just go MCP toolkit, download the things that I want to use, and when you click on one, you'll find somewhere a configuration like this. This is for DuckDuckGo. You can see the command is Docker, and there's a couple of things over here. But this is not something that you need to worry about. You just need to copy paste into the MCP JSON. So if you're using Claude Desktop, if you're using LLM Studio or any other tool that supports MCPs, there's a great chance that you have an MCP JSON, and you just paste all of that string over there. And you have your MCPs. And what's really cool is in most of the tools that you're using for chat, you're having here a choice of how many MCPs you want to use in this conversation. So let's do a quick demo. Now, full disclosure, I have an issue with my Raspberry Pi. Occasionally, the header for my SSD stops working. So there exists a possibility that this demo may not work. Demo gods, have my Raspberry Pi working? Yes, yes. Okay, demo will work. So what I'm going to do here is I'm going to add a MCP Home Assistant, because a lot of people tell me, "Hey, you're doing all of these demos for for, building your own home automation, but you don't actually control your home automation. You just have a virtualized home automation thingy on a Blazor WASM. That's not a real home automation. And then I said, look, fine, I will automate my home with AI. So I installed the MCP for Home Assistant. I will not show you the configuration because it has a secret in it, but what you can do here is you can go tab Program, Install, Edit MCP, and it's all the way down. But I'm not going to show you because I'm not trusting you with my secret. So what I'm going to do is I'm going to say turn on kitchen lights to be red. Like that. And here to preview, currently it's off. Now what I have configured here is that it asks me every single time. So if you go over here, you can see that everything is asked. You can actually do always allow, but there's a security reason why I don't like that. I prefer it to ask, especially if you have a little bit too much access, if the AI has too much access to certain things, as well as being able to read something that might not be fully sanitized, like GitHub issues that may instruct it to do things that you don't want. Be careful with that. I prefer it to ask. So I'm going to proceed. So here I can expand. We can see the arguments. So it wants to do something with the kitchen. And it says, hey, mate, you can't do that. And it's like, LLM is sad. And it's like, okay, what about this? And it could not from kitchen light. Okay, that's interesting. Usually it works. Oh, I know why it doesn't work. It's nice to have a good system prompt, right? It's even more awesome that I can actually select the system prompt that I right now want. By the way, if anyone is interested in PG-13 friendly Annie from XGrok, we managed to reverse engineer and actually make it non-toxic. It was a very hard job. Okay, generated fields. Okay, so that's probably because we changed the system prompt mid. Okay, so what's now happening is we are trying to get the state of my home. So we can see here, there's a lot of a big JSON. It tells it, what lights are on, what's off and stuff like that. But that also will give it the name of my lights. So now it will be able to figure out what to actually turn on. And that's also another bug that I occasionally see. It wasn't happening a couple of weeks ago. I hope they're going to fix it. Sometimes when I mess too much with the chat, the MCP might break apart and just go into loop calling in the same request. So let's try this again. This is mostly a problem because I'm just changing system prompts and stuff like that mid-flight and then just regenerate things. Generally speaking, you know, I'm kidding me. Okay, you already called this. Turn on the light, please. So yeah, you can communicate with LLM saying, this is why I'm not. Okay. Let me give another try. So we have actually done. So this is what was supposed to happen. It will do kitchen, rat, and we get a good response. But let me try to just copy this. Actually, sometimes what helps is if I turn LM off, LM Studio. I'll give one more try. Unfortunately 2-3 weeks ago they made an update and that is not working as perfectly as it used to. I'm really hoping that's going to fix that. But need to load the model. When Coda, here, load. And run. Please, demigods, make it lag. Yay! So we turn on the kitchen lights. Now, there's a far more riskier demo where I actually ask it to check the lights of the golden bridge and then set the kitchen lights to that color. But say, change the color of kitchen lights to give me a random object that has a color. Apple.
Don't do Apple because you tell her like.
Yeah. Banana. Banana color. So I can just pick up a random object and it will first try to do banana and then figure out, well, actually, it needs to actually do a proper color. It goes through the cycle again. Such a shame. But what I can do is check the colors of Story Bridge and then turn my kitchen lights to that color. And same color. Okay. Pink. So is it pink?
Yes,
Yeah, it's pink. There we go. I set my kitchen lights to pink. Also, there's some people that told me, hey, why don't you do this on .NET 9? Simple. It's coming. But the reason why I didn't do this sooner is because now I can just do .home assistant and say, turn kitchen lights off. And then I was thinking, well, I'm literally doing the same thing, but in Blazor. It's not useful, that much useful than, just running something like Raycast. So I'm trying to find a good demo where, I can do it with something else, like maybe find some data from the internet and do some funky things to make the demo a little bit more interesting so that I can show that I can be better than Raycast and Google Home and stuff like that. So if we look at the lights, yeah, you can see that the kitchen lights are off. So what that means is that with this, we have an get it done AI. So if we say send a scheduled email to John at 9 a.m., the AI is going to say, is that okay? And it's going to show you the email. And you're like, yep. And it's going to send the email scheduled. And then you can just chill. And that's what they call get it done AI. So in summary, I've shown you how powerful offline AIs can be. And if there's any questions, I'm open to answer for more. And we have LM Studio. It's a really powerful tool. Not only has a good desktop application where you can easily download models, switch between them, it's even more powerful than Llama when you have multiple graphics cards and stuff like that. It's one of the few that actually allows you to load balance all of that. It has a CLI, it has endpoint, it has even RAG. So it has pretty much almost everything in one package, everything offline. Really cool tool. I've shown you how you can leverage in .NET 9. Check the .NET 9 AI extensions. They're really cool. And also MCPs is what gives the LLMs capability to interact with everything that is outside them. Like LLM here, the LM Studio, is fully offline. This is running fully offline, but with MCP, they can get outside and actually connect to my home automation and then turn on the kitchen lights. Now imagine this is in my intranet, and I can have a AI that never needs to exit my network. Everything works within my network. And that's really the power of all of this. And with that, thank you. So the question is, for the context, can you have it offline? So first off, you can scan the QR code for getting the prices. But yes, you can do that. I'll just wait a second for the scan. But what you can do in, say, in LM Studio is you can use the integrated reg that allows you to vectorize whatever text you have. And then you can store that into your own vector database. Although LM Studio even comes with that. So it's literally, the way it works is, so if we're creating a new chat, I can enable it almost like a MCP, and then it will be able to extract data from the documents. And it stores them in its own database, which is really cool. And in the way you do that is basically just upload the file from here. You can put lots of different formats like PDFs and stuff. Does that answer your question?
Amazing. Anyone else? No, I have a question from Anurada from YouTube though, and he would like to know, well, they would like to know, so I want to make assumptions. What's the best hardware for running this kind of setup?
So right now, being a Windows fan, I'm having a Mac, an Apple. There's a reason for that is because this is the AI machine. I'm starting to, love Apple more. Still have some of heart on Windows though. But yeah, if you want to work with AI, I think Apple, like for the performance and the size of models that you can run, I don't think there's even a competition. Like if you want to run a 70, 80 billion model for under $6,000, this is it.
I'll tell you that, and you argue with me.
So Google told me, I told you so. Well, yeah. Yeah, like the GPUs are super expensive that can run that kind of stuff. Yeah.
Sounds really fun. If I were just to go out and buy a bunch of Arduinos and Raspberry Pis and maybe even Mac Minis and just start letting they run around and roll right out, what are some of the things I should be worried about the chat along?
So the question is, what if I buy some Raspberry Pis, Arduinos and stuff like that? One is that you likely won't be able to run very powerful AIs. There's some that promises to be fairly decent, despite the size. I think it's the Liquid AI. I haven't tested too much, and this one is designed to run on a camera. So it can recognize things, say you have it for security or stuff like that. The Liquid AI, which only has 1.6 billion, it's like 2 gigabytes. If you buy a Raspberry Pi that is at least 4 gigabyte, 4 gigabytes, ideally 8, because you need for other stuff, right? This one would work. The problem that you may have is that even if you buy a lot of them and you try to stack to them, they won't get even close to a Mac Mini performance.
So what if I did just buy a bunch of Mac Minis?
If you buy a bunch of Mac Minis, congratulations. It's and yes, LM Studio, I don't think can connect them together to be able to run a big model. There are ways to run several several different Mac Minis to run one bigger model. If you buy the studio ones, they have some connections that are really fast. But with regular Mac Minis, generally you won't see that much performance improvements. The bigger thing is that you'll be able to run bigger models.
Right.
Does this use a lot of energy? Is this something you need to be concerned about your power bill?
Okay, so this is also where the Apple Silicon kind of wipes the floor with Windows, unfortunately. My Mac Mini consumed about 10 watts when running a small LLM offline, compared to my GPU that is idle at 40 watts. No, it doesn't consume much power. Like with Apple Silicon, you do get a very good efficiency. Truth to be told, like if you run like really big models, yes, the consumption is going to be a bit bigger, but you know, are you going to really run like 24 hours, 7 the models? Likely not. That's one thing. And the other thing is this model caps at about 90 watts, I think, or 120 watts. That's the max that it can pull. My desktop runs idle at 70 watts. So my desktop almost consumes as much as this machine running at full power.
Okay. We have a follow-up question from YouTube. They would like to know, is a Windows PC with RTX 5090 okay?
Yeah, so any external GPU is good. Like at home, I have 3080 with 12 gigabytes of RAM. And now, if that is your only GPU, aim for up to 10 gigabytes, the size of the LLMs. Give a little bit space for your GPU drivers and stuff like that. But if you have a laptop or a desktop that has an integrated graphics card as well as external graphics card, this is where you can then push it much closer to 12 gigabytes. So yeah, this, and if I remember correctly, the 5090 goes up to 30 gigabytes. So yeah, you can actually run pretty good. Like the Quen3 coder, that is my favorite one, would fit on that.
Amazing. Any other questions? Beautiful. Well, please join me in thanking JK for such an awesome talk. Thank you for coming out to the Brisbane User Group, JK.
Thank you for having me. And signing off from Brisbane.